Did you know that there is a special number which is loved by nature and has fascinated mathematicians, scientists, artists, architects, and even musicians for centuries? But like all celebrities, it has been the victim of fake news. Let's find this number.
Say we have a line divided into two segments. The larger segment is phi and the smaller segment is 1. In this case, the ratio of these two segments is equal to the ratio of the entire segment of the larger segment phi. When we cross multiply, we get a quadratic equation, and solving it gives us two solutions. The positive solution gives us phi. Phi is known as the golden ratio. It is an irrational number. But what is so unique about the golden ratio? We can compare irrational numbers by seeing how quickly we can get a rational number whose value is close to the number. When comparing phi and pi, we notice that pi is rationally estimated accurately very quickly, as the rational numbers shown are getting closer and closer to its actual value. This makes it a weak irrational number. On the other hand, phi converges very slowly and is the strongest irrational number.
The fact that the golden ratio is the most irrational number manifests itself in a spectacular fashion in nature. Ever wonder how a sunflower packs its seeds? Let's use a simple computer model to understand how a sunflower packs its seeds. Each new seed is placed at a constant angle to the previous seed. At 0 degrees with no rotation, there is a lot of wasted space. For a quarter of rotation, it first places a seed, then the next one at 90 degrees, and so on. This is better, but far from ideal. How about 1/3 and 1/5 of a full rotation? Interestingly, the spokes form correspond to the number in the denominator. So rational numbers of a full rotation give us spokes. What about an irrational number like pi? Irrational numbers give spirals. However, since pi is a weak irrational number, we see traces of a spiral, but it still has 7 spokes. Remember, 22/7 is a good approximation of pi, and spokes dominate spirals in this case. Now let's try the rotation with the golden angle and look how optimally the seeds are packed.
Notice that the ratio of anti-clockwise to clockwise spirals tends to the golden ratio, and these numbers are in fact a part of the Fibonacci sequence. It is spectacular to observe nature's choice for the strongest irrational number.
We have frequently seen tiles of equilateral triangles and squares which are periodic, meaning the pattern repeats itself. They display long-range order. Equilateral triangles exhibit 3-fold symmetry, and squares 4-fold symmetry. However, regular pentagons cannot be filled without gaps. In the 70s, Roger Penrose discovered a set of tiles that fixed the problem of the forbidden 5-fold symmetry. This is a pair of fat and thin rhombi. Notice the presence of the golden ratio. By using appropriate matching rules, we get the plane filling pattern. Although not strictly periodic, they display long-range order. The amazing thing to observe is that the ratio of fat to thin rhombi approaches the golden ratio for large areas. This idea has helped develop the field of quasi-crystals in physics. The mind-blowing aspect of the golden ratio is that it poses more questions than it answers. And searching for some of these answers might just lead us in the glorious quest of the next big discovery.